Hello everyone, welcome back to the channel. So in last video we already discussed a lot about what is hash table. We did few problems over that and we also understood what is hash set. So in this video we are going to understand a bit more about hashing and we are also going to understand what is hash collision. And the hash collision is a problem. Basically we are going to understand its solution as well, that is chaining and open addressing. How we solve this problem, we'll look into all that. So let's start with the explanation. So we discussed for the hashing that in hash table, whenever we want to store a key at a particular location, right, it goes through a hash function, right? So how does that hash function actually looks like? We are going to have a look at it. So let's say you're using strings as keys, right? So I have taken, let's say, my name as a single key. So how internally hash function would be working? There will be a function called hash, okay, which will be taking this key, and just for an example, how it will be calculating the index, that's what I have taken here in this hash function. So how I am calculating that hash for that particular value, I'm converting this string to a character array and I'm adding all of the characters which are there in this particular string, right? Let's say there are so many characters, okay, and their addition goes like 200, 500, 700 something, right? But the array that you're using internally to implement this hash table, right, for that the size is 10 only. So what you're doing in the end, once your hash is calculated, what you're doing the mod with the size of the array, okay? Size of the array is 10. That for now I have taken, you can take is 100,000, whatever the size you want to have for the array, where array is the underlying implementation data structure for the hash table, okay? So we have passed this key which is our string, and here we have calculated the hash, and to make sure that hash index value fits to our array, we are doing mod with the size of the array, and it is returning some value inside the value of array size. So if you take the mod for it, so if I try to run this, right, you will get some value within size 10. I'll show you the same thing with 100 as well. So you're getting 4 index value, right? Let's say you have internally 100 as the size of array. Now whatever the size you will be, whatever the hash key that you will be getting, right, where you want to store the value, that particular entry in the memory, see now you're getting 44. This value is within 100 only, right? So based on the size, once the hash is calculated, we are doing the mod with the array size so that we can store it within the array, okay? This is some more explanation over hashing, right? How internally your hash function works and all. Let's say you are passing this Shubham, my name is a string as a key, right? Now let's see you're passing one more string, okay? But after the calculating the hash value, right, you're getting the same hash value which you are getting earlier, right? Now in this case what will happen, there will be already one value present at that particular hash location, okay? Now this scenario, when your two hash key in the memory collides, right, where one value is already there, that is what is called hash collision, okay? When two different keys generated the same hash value, right? So this scenario is called hash collision. Now how we need to solve this particular problem so that you can store that key at some different location as well. Now how do you do that? Now you do that through these two techniques. First one is chaining, second one is open addressing, okay? So let's read what you have written here. So in chaining we use a linked list and add the collided item at the end of the linked list. So this is how chaining works basically. Let's say your array size is 4, okay, 0, 1, 2, 3. First time when you calculated the hash for a particular value, for the item 1, let's call that item 1, okay? For item 1 you calculated a hash value that will be 0. Now again for some different item you calculated a hash value that came 2. Now for some item 3 you calculated a hash value, again it came 0. So that's when the hash collision will happen. So in case of chaining, what you'll do, let's say these all are individual linked list. At 0 there is a linked list, at the index 1 there is a linked list. So you will add that item here as item 3. And again if the hash collision happens at the same index, you will store it in the, you store that item as the next item in the array list, item 4. Okay, so that's what you do when you're trying to solve this hash collision using chaining technique. Okay, now let's look at the other solution, which is open addressing. Now in open addressing, what you do here, we look for alternate address to store the item. Okay, so basically when the collision happens in chaining, right, in case of linked list you added the item at the end of the linked list, but here in open addressing you don't have a linked list. So let's say here if a collision happens, right, you will be checking for some alternate address. Let's say you're checking for the next value, next address, available address itself. Let's say index 1 is available, so you store your item 3 here. Okay, so that's what you're doing in open addressing. Now open addressing is actually can be done in 3 ways. There is linear probing, quadratic probing, and double hashing. So in linear probing, what you're doing, you're checking for the immediate next available slot. So when the collision happens at 0 index, right, we immediately did +1 with the value of the hash value, and we got the first index where there was no item present. So we stored the item 3 at the index 1. Okay, now this is what we call linear probing. With that particular hash, we are adding one more I value. Okay, I could be some counter value or something. Now what is the other way of doing it? That is quadratic probing. Here, you know, when you are trying to find, let's say currently item is there at first index, item is there 2 index, right? So these items are actually in a combined way forming a cluster. So if you're using linear probing, you will have to, you know, jump through each and every index to find the available slot. That's when what you do a square of your I value. Okay, and then you add it to a hash value so that you can get the next available address faster. Okay, but in both of these, you see, it can store any more values when the array is full. Okay, when the array gets full, you cannot actually store any more values. Now this problem is not there with the chaining technique, because in chaining you have linked list, and in linked list you can keep on adding more and more items no matter what. Okay, so you understood what is linear probing and quadratic probing. Now there is another technique in the open addressing which is called double hashing. Now here we are actually using the same hash function with some additional hash value, so that your collision that you are getting, right, you won't be getting it very frequently. Okay, so what we have done here, the formula is hash key, a simple hash function, whatever you're using existing, then you add another hash function value, that means another hash value, and multiply it with I. Now how your another hash function is calculated? Like this. Now hash 2 is equal to prime minus key mod of prime, right? So this is how your double hashing is, basically double hashing value is calculated. So let's have a recap. We understood what is hashing, right, and how in a basic way hashing happens. That's what we have seen here, and how it, you know, manages with the size of the array, considering the underlying data structure is the array. Okay, now when you are using some different key but you're getting a same hash value, in that way hash collision happens. Okay, now when the collision happens, you have two ways of resolving it. First is chaining and the second one is open addressing. Now in chaining you're using linked list. Whenever the collision happens, you store that value at the end of the linked list. Now in case of open addressing, you know, you keep on looking for alternate available address. Okay, now for open addressing we have, you know, learned three techniques: linear probing, quadratic probing, and double hashing. In linear probing, with the hash you're adding a single I value. In quadratic probing, you're adding the square of the I value. And in double hashing, you are calculating another hash function and multiplying it with I. Okay, this is how. Now these are the terminologies which are important to understand for hash table. Okay, so you know the background as well, what is hash collision, what is hashing, and what is the solution that we are using. Now we'll be implementing this hash table by ourselves. We'll be implementing those put method, get method, and remove method. We'll be understanding by ourselves how the logic is implemented internally. So there we'll be using the concept of chaining, where whenever there is a conflict, right, you will add that value at the end of the linked list. So yeah, that's all I wanted to explain as part of this video. See you in the next one. May the source be with you.